Lastly, we'll introduce Poisson's ratio. When a material is loaded axially, strains are generated in the radial direction, perpendicular to the direction of loading. Because mass is conserved, when a material is elongated under tensile loading, the cross-sectional area decreases. Conversely, as a material is compressed, the cross-sectional area increases as length decreases. Poisson's ratio relates the transverse strain to the axial strain, where nu is equal to the negative transverse strain per axial strain. Note that this relation is only valid for uniaxial loading. Nu is a material property. It exists between 0.27 and 0.3 for steels and around 0.32 for aluminum. Poisson's ratio can also be used to relate the elastic modulus to the shear modulus. The modulus of elasticity, E, is equal to 2 times the quantity 1 plus nu times the shear modulus. For example, let's consider a rod with a 16 millimeter diameter and a length of 500 millimeters that experiences a load of 12 kilonewtons. Given the deformation in the axial direction is 300 micrometers and the diameter decreases by 2.4 micrometers, let's determine the modulus of elasticity and Poisson's ratio for this rod. First, we'll calculate the average normal stress, which is equal to the internal reactionary force per cross-sectional area. In this case, we have 4 times 12 kilonewtons per pi times the diameter, which is 0.016 meters squared, and we get that the average normal stress is 59.7 megapascals. Next, we'll calculate the average axial strain, which is the deformation in the axial direction per the original length. This is equal to 300 micrometers per 0.5 meters, which gives the average axial strain of 600 mu. The modulus of elasticity is found via the stress-strain relationship. E is equal to the average normal stress per average axial strain. So, 59.7 megapascals per 600 mu gives us 99.5 gigapascals. The average transverse strain is found as the deformation in the transverse direction per the characteristic length in the transverse direction. In this case, delta is equal to minus 2.4 micrometers. This quantity is negative because the diameter has decreased. Note that L is not the length of the bar in this case, it's the diameter, so we'll use the value 0.016 meters. This gives us the transverse strain equal to negative 150 mu. We can find Poisson's ratio as the negative transverse strain per the axial strain. So, the negative of minus 150 mu per 600 mu gives us nu equal to 0.25.